Alright, so the standard deviation formula is going to look like this. And as I write this, you should note that it's going to look a little bit familiar. And specifically, it's written like this. S is our standard deviation. So I'll put this here as well, and I'll also put S squared up here, just for when this turns into notes. Alright, so our standard deviation is given by S. And the formula to find the standard deviation is the square root of the sum of x minus x bar squared over n minus 1. In other words, to find the standard deviation, what we're doing is we're taking the variance, and we are taking the square root of it. So what this does is that instead of giving us an answer that's written out in units squared, it's going to give us an answer that's written out in the same units as the variable. So, as I said before, the variance is used to find other useful measures, and the most useful measure that we're going to talk about that the variance is used to find is the standard deviation. So I'm not going to go through calculating all of this stuff again, because we already did it. So the sum of x minus x bar squared over n minus 1 is equal to 2.27 or s squared. And we know this because we just went through all the steps to calculate that. But what I will do, just to avoid any confusion here, is I'm going to write out what the different components of this mean. Where this is, again, the sum of, so sigma means sum of, x is each observation, x bar is the sample mean. So all of these mean the exact same things that they did up here. And n is the total number of observations. So because each of these different characters means exactly the same thing as it did in our variance equation, which is written here and here, it's the same thing. Because all these mean the same things, it means that everything inside the square root is going to be calculated exactly the same as this whole equation right here. So this comes out to 2.27. So if we want to find our standard deviation, all we have to do is take the square root of the variance that we already found. And so we can plug in this value that we found for the variance in here, because the standard deviation is just the square root of the variance. So if we plug this in, we can then just calculate this in a calculator, and if you take the square root of 2.27, you get a value of 1.51. And importantly for our purposes, the value is back in units of arrests. So we would say that the standard deviation is 1.51 arrests. And so the interpretation of this, going back to the slide, is that the size of an average deviation in our sample is 1.51. Or in other words, the average distance that the observations in our sample are from the mean is 1.51 arrests. So on average, looking at these different observations we have, on average, the distance that each one of these is away from our mean of 1.5 is about 1.5 arrests as well. So this is describing how spread out our different observations in our sample are from the mean. And we're saying that on average, the size of that spread is going to be given by 1.51 arrests. So what I'm going to do next is go through an example of the mean and standard deviation that'll be a little bit more straightforward. Because in these last slides and last examples, I'm really walking you through the logic of what all this stuff means as well as how to get there. In the next example, I'm going to just go through it straight without any of this extra nonsense. And specifically, what we're going to do is go through some data with fictional judges. And so this is the example that I call the witch judge example. And back in the days of real class, I'd have you guys calculate this in class and then we'd talk about it. But these days I just do it for you. So in the witch judge example, we have data on the sentences given out by 2 different judges for murder. So we're going to imagine that you're on trial for murder, and your lawyer is giving you the option to schedule your case with one of 2 judges. And what I'm going to write out here are the sentences given out for murder by each judge, and the last 10 sentences they assigned. So Judge A here assigned the following sentences for murder. And again, these are the last 10 sentences assigned by Judge A in years. So here's Judge A. The last 10 sentences assigned by Judge A for murder were 10 years, 9 years, 8 years, 11 years, 13 years, 10 years, 7 years, 11 years, 12 years, and 9 years. So that's one of the judges that you can have your case assigned to. Judge B, so this is the other judge that you could get, has given the following sentences for murder. 2 years, 16 years, 9 years, 4 years, and so on. I'll write them out. And I realize it looks like I'm spelling years with 2 E's. That's supposed to be an A. And 15 years. 10, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Alright, so I'll copy down correctly. So these are your 2 judges who you could get a trial with. Judge A has assigned these sentences for the past 10 murders they've come across. Judge B has assigned these sentences for the last 10 murders they have had as cases. And what we're going to do here is we're going to look at the mean and standard deviation for each judge and then think about who you'd rather have on your case. So I'm going to start by finding the mean for each one. So here we're looking for the mean and standard deviation. And so if we want to find and here we have n equals 10 and n equals 10. So I'm actually going to flip over another page just so that there's a little bit more room. And we'll start calculating. So here we have Judge A, and we're going to start by finding the mean for Judge A. And although I realize this is annoying, I'm actually going to write out all these numbers again. Sometimes I don't think about formatting when I write things down, and then I get to this point and do this. Alright, so here's the same data that we had for Judge A. The first thing we're going to do is find the mean. And the mean, as you guys know, is given by this equation, which is the sum of your different x values divided by your total number of observations. So this means that we're going to do what we always do to find the mean, and we're going to add up these values together and divide by the total number of observations. So to find our mean, we have 10 plus 9 plus 8 plus 11 plus 13 plus 10 plus 7 plus 11 plus 12 plus 9. And it's going to be all of this over 10 because we have 10 different sentences that we're looking at. So this is a sample of the last 10 sentences this judge has assigned. And if you do all of this, it comes out to 100 over 10, or an average sentence of 10 years. All right, and we'll do the same thing for Judge B. So the first thing we're going to compare them on is the average sentence that they assigned. So Judge B, again, our sentence lengths here are 2 years, 16 years, 9 years, 4 years, 14 years, and so on. All right, so these are the judges assigned, the sentences assigned by Judge B. And again, we're looking at the last 10 sentences assigned. So we have 10 observations total. We'll find the mean with our mean formula. And so to do that, as we have been doing with all of our data here, we'll be adding up these observations and dividing by 10, which is our total number of observations. So here we have 2 plus 16 plus 9 plus 4 plus 14 plus 17 plus 1 plus 3 plus 9 plus 15, and all of that over 10 for total number of observations. If you go through this math, you should come out with 90 over 10, or an average sentence of 9 years. All right, so question answered, right? Judge B is more lenient than Judge A. Judge B assigns an average sentence of 9 years, so obviously we want to go with Judge B. The issue here is that we haven't completely looked at what's going on in this data. And if you'll notice just at a glance, you can see that Judge A here doesn't give any sentences that are longer than 13 years, while Judge B is hitting some people with 15, 16, and 17-year sentences. And so what we're going to do here is take a look at the standard deviation and see what that tells us about the sentencing practices of these two judges. So for Judge A, when we want to find the standard deviation, we're going to start the same way that we did before, and we're going to list out the observations that we have. And so to find the standard deviation, we're going to start by listing the observations in our sample. Okay, and what I have is another space problem. I'm way too deep into this video to stop it, so we're just going to do this. All right, so here we're going to be looking at the standard deviation. We found the mean, now we're going to look at the standard deviation. The first thing that you want to do in finding the standard deviation is find the deviations for each of our observations. So we want to find x minus x bar for each of our different observations. Well, we know x bar because we already calculated the mean. And so we know that our x bar is 10 years. So we're going to just plug in 10 here in this column. So to find the deviation, or to find the distance that each of our observations is from the mean, we're going to subtract these two things for each of our different observations. So here we get a deviation of 0 from 10 minus 10, deviation of -1, 9 minus 10, and so on going down the line. All the way down to -1 here. Again, if you want to check your work, you can add up all of these together and they should come out to 0. The next thing we want to do to find the standard deviation is to square each of our deviations. So here we're going to be taking each of these deviations and squaring it. So here, 0 squared is still 0, -1 squared becomes 1, -2 squared becomes 4, and so on down the line. So again, each of these values are our deviations squared. So in looking for the standard deviation, we're going to be using the following formula. Our standard deviation formula, which is the sum of your squared deviations over n minus 1. What we have now is a squared deviation for each of our observations. The next thing we want to do is add all of these together. And if you add these values together, which normally I would do under here, but I'll just say format it like this instead. If you add all of these together, you get 30. So 0 plus 1 plus 4 plus 1 plus 9 plus 9 plus 1 plus 4 plus 1 comes out to 30. And if you remember, when you add all these squared deviations together, the value that you get is also written like this, or the sum of x minus x bar squared. So you've added these together, you have 30, and now you know that you can plug in 30 for everything that is in the numerator of this equation. So if we want to find our standard deviation, we're going to plug in 30 up here. We're going to plug in 10 for n because we have 10 observations, subtract by 1, and then we're just doing some math here. So if we do all this out and we take the square root of 30 divided by 10 minus 1, we're going to get 1.83 years. So the standard deviation for judge A is 1.83 years. And what this means is that the average distance between the observations and our mean of 10 is 1.83 years. So on average, the sentences assigned by this judge are about 1.83 years away from the mean of 10 on either side. Well, how about judge B? And I'm going to do this one even more quickly. So we want to find the standard deviation for judge B. And I'm going through so many examples of this because I am going to have you guys calculate standard deviations by hand, and it's kind of a lot to do unless you've got a sense for what all the steps are. But if you're feeling very comfortable with standard deviation here, you can fast forward through this if you want to. All right, so with the standard deviation for judge B, we are again going to list out the different observations that we have in our data. So here, judge B's observations are these last 10 sentences assigned by judge B. So we have 2 years, 16 years, 9 years, 4 years, 14 years, 17 years, and so on. The next thing we're going to do is we're going to write out the mean here so that we can find the deviation for each of these observations. So here we calculated the mean for judge B to be 9 years, so our mean is 9 for each of these. So write out each observation and then write out the mean. The next thing you want to do is subtract these two to find your deviation for each observation. And when you do that, 2 minus 9, you get -7, 16 minus 9, you get 7, and so on down the line here. If you want to double check your work, again, you can see that if you add all these together, they come out to 0. That's how we know we have the right deviations. Next step is to square our deviations. And so we're going to take each of these and square it, which gives us 49, 49, 0, 25, 25, 64, 64, 36, 0, and 36. And one thing to note here is that when you're squaring deviations, sometimes you are going to get what seem like unreasonably large numbers, and that's okay. That's to be expected when you are squaring deviations. All right, your next step here is to add them all together. So we're trying to get this phrase of the sum of our squared deviations. We're going to take the sum of everything we have here. When we do this, we get a sum of 348 years, which again is going to be equal to our sum of x minus our sum of x minus x bar squared. So now we're going to start plugging stuff into our standard deviation equation. So our standard deviation equation looks like this. You've got your sum of x minus x bar squared over n minus 1. And we're going to plug in 348 for this here. So our sum of squared deviations. And we're going to subtract by the total number of observations that we have, which is 10, and subtract 1. If you do all this, calculate it out in your calculator or whatever you're using for calculations, you should get a standard deviation of 6.22 years. And the interpretation of this standard deviation then is that for judge B, the average distance between each observation and the mean is about 6.22 years. So on average, the sentences assigned by the judge are with around 6.22 years away from the mean on either side. And what this tells us is that Judge A is much, much more consistent in sentencing than Judge B, who is all over the map. So if you were, thinking about which judge you would want to deal with, you get to choose which judge to have your trial with, you would want to think about both of those things. So Judge B, on average, is slightly more lenient than Judge A. But with Judge A, you know more or less what you're going to get. And Judge A is a lot more consistent than Judge B. And with Judge A, you know that everything's going to be clustered pretty tightly around this mean of 10 years. You don't have a whole lot of sentences that are much less than 10 years. You don't have a whole lot of sentences that are much more than 10 years. With Judge B, on the other hand, it's kind of a crapshoot. And you have some sentences that are much greater than 10 years, and you have some sentences that are much less than 10 years, but you don't really know what you're going to get, because there's a whole lot of variability there. And that amount of variability is reflected in the standard deviation that we have here. All right, so with these examples, we're now going to head back to the PowerPoint. We're going to talk a little bit about what the mean and standard deviation look like, and then we'll go through a pretty brief summary of statistical software and what you can do with it.